Hi everybody, so this is the video for section A, which is Introduction to Matrices. So a vocabulary note to start, matrices is plural of matrix. So with an X is singular, with a CES is plural. So a matrix is an array of numbers and it has a variety of uses. Originally it was used to help solve simultaneous equations, which we will get to later in this unit. Now you'll see it in business, you might see it in computer science, you might see it in physics. It has a variety of uses in a variety of disciplines. So again, it's an array of numbers. It is referred to as a blank by blank matrix. So we read that X as the word by. So this number represents the number of rows the matrix has, and that number represents the number of columns. So rows horizontally, columns vertically. So this would be referred to as a 2, because it has 2 rows, by 3, because it has 3 columns matrix. So a 2 by 3 matrix, and that's called the order of the matrix. So if you're asked for the order of a matrix, you're looking at determining how many rows and how many columns that has. So this, for example, would be a 2 by 1 matrix. And if you only have a single column, sometimes that will be referred to as a column matrix, or potentially a column vector. That's more of a science word. This is referred to then as a 1 by 3 matrix. And again, similar to the column, if it only has 1 row, you would call that a row matrix or a row vector. And then this one would be a 2 by 2 matrix. And if you have the same number of rows as you have columns, you might refer to that as a square matrix. So that's just a little bit of terminology. The individual numbers in a matrix, those are referred to as the elements. And the elements all have a specific location in the matrix. So this element is in row 1, column 2. So that element is in row 1, column 2. Okay, so the last thing we're going to get to in the introduction is this idea of matrix equality. So 2 matrices are equal if they have exactly the same shape and exactly the same elements in corresponding positions. Complicated way of saying they have to look exactly the same to be equal. So they must have the same number of rows, same number of columns, and in each position you must have the same value, the same element. So when we see the equal sign, we know automatically that they are already equal. So this kind of a setup can allow us to solve for the unknowns here. So if we have identical elements in identical places in our 2 matrices, then we know that P must equal 9, because we see that these 2 matrices are equal to each other. Then we know that Q plus 1 must equal -2, and we can solve that out to figure out what Q actually is by subtracting 1 from each side. So we get Q is equal to -3. We see here that R squared is equal to 4. And we can solve for R by square rooting. So we see that R is equal to plus or minus 2. And then last but not least, we have S is equal to 5, or 5 is equal to S, if we want to keep sort of the order of our little linear equations the same. So then that allows us to solve for each of the unknowns in our 2 matrices, because we see that they are equal, meaning exactly the same shape and exactly the same elements in corresponding positions. So that's about it for the introduction to matrices. We're going to see a lot of different things throughout the unit, but that does it for section A.